Welcome back to the formulaic approach. Now let us see some questions on the eyes as an optical instrument and refraction. I already have videos on all this, so do well to check those videos out. And if you want me to release a long content on wave, everything on waves, both light, sound, waves, etc., let me know in the comment section, or you just go and check my waves videos that I've already made. All right. Then I also thank those of you that are reaching out for me to make you contents. So do well to, and that you are watching and giving the videos thumbs up. God bless you. So you can also reach out to me for any of your contents to, explain. Now we have, but make sure you are subscribed. Okay. Now the first one says images formed by a diverging lens are always dashed. So what's a diverging lens? A diverging lens, like the name implies, diverges light, yeah? So it's going to be a concave lens. You see that? So a concave lens, once a ray of light gets here to the center of the distance, it diverges. A ray of light gets here at the center, from the center it diverges, okay? But the other type of lens which you have, which is called convex, this is concave or diverging, this is convex or converging. So when a ray enters here, it converges. A ray enters here, it converges. Is that clear? So you notice they are being refracted, not reflected. The ray is not going back because this is not a mirror, but a lens. So we have images are now formed by this mirror here, by this lens rather here, is always what? I've told you that before. Now let's first stick out the ones that don't make sense, because I've told you in that video of my image formation on lenses. Okay. We have erect, real, and magnified. If you are erect, if the image is erect, if the object is, the image is erect, it will not be real. They don't go along. Yeah, I've told you before. Inverted and real and diminished, this one makes sense. But it is not the case with in concave lens. I'm going to show you. Okay, I guess that's what I should do. Let me show you this. So if I draw my concave lens, here's my principal axis, my mirror here, okay? So I put my F here, my F prime here, and my 2F here, 2F prime here, so that 2F will be here. Let's place somebody here, our object. So you draw a ray of light. Once it gets to this guy, it diverges, and diverges as though it were coming from the principal focus, right? Then if you draw a ray of light that is that diverges around here, if you draw a ray of light that is coming through the center of curvature, it goes, not center of curvature, sorry, through the pole, this middle here, it goes directly undeviated, right? So since it goes undeviated, this place where they meet is where your image will be formed. Does that make sense? I hope that makes sense. Now another way to draw that is, if I draw a ray that comes here, now, if I draw a ray that comes from the principal focus, it should a ray that is coming from the principal focus, okay, it can't converge, okay, it cannot do that. All right, so here's my point. You can see already, using these two rays, I'll be able to create my image here. What do you see of the image? The image is erect. So anyone that is inverted is wrong. Makes sense? So the answer is erect. You see, I don't even need to check. I know it is erect, it will be virtual, and it will be diminished. You see, the size is also small. It's diminished. Does that make sense now? Now, the use of lens is not applicable to which one? A projector uses lens. It's an optical instrument. Human eye is an optical instrument. It has a convex lens. Periscope and telescope. Telescope uses lens, two lenses, the objective and the eyepiece. So it is also it applies lenses. So periscope is the one that does not apply lens. So the answer is periscope. And periscope uses a mirror basically, or two prisms, two triangular prisms. Okay, triangular prisms. Triangular prisms that will place something like this. Okay, such that an image you get here, will. This mirror, it uses a mirror. Okay, it uses a mirror. Some use triangular prisms. Okay. Then, in comparing the camera and the human eye, the film of the camera functions as the retina. The iris is the one, I've showed you the camera. So that film is this part here, makes sense. So this is the film. So this is the camera, like the casing that we have where your mirror, your guy is. So this is your lens, this here is your diaphragm, and this diaphragm is what functions as the pupil, as the diaphragm is what functions as the diaphragm functions as the iris. Then that's the lens functioning as the lens of the eye. Then this is the film. The film is the one functioning as the retina. Images are formed on it. Is that clear? So then the short eye here is the one that controls the amount of, the length of exposure to light. Is what that controls the length of exposure to light. While this one, the diaphragm is the one that controls the amount of light. Okay, so that would be pupil. That would be pupil. So it's the diaphragm that controls the amount of light that actually enters. Okay, shorter there, this is the shorter here. It controls the length of light. So the speed of exposure to light is controlled by then the diaphragm, or the stop, is the one that regulates the amount of light that actually enters that the eye gets. Okay, so depending on the level of the amount of light in the environment, the shorter that diaphragm will control the amount of light that we enter. Okay, and so that is the work of the pupil primarily, because the iris rather, because the iris is what controls the size of the pupils of the pupil. Okay, it's the one that controls the amount of exposure that the lens actually gets. Okay, so that's primarily it. So we have the retina is the film. Then of course the cornea is just the clear portion in front. Which of these is used in the, make sure to check out my video on that. I've already explained all of this, okay? I don't want to begin to dig deep into it again. Which of these is used in the correction of short-sightedness? Short-sightedness is also called myopia. That one is corrected by this concave, so that's concave. So the answer is concave lens, not mirror, okay? You don't use mirror. With mirror, you can't see the other side, okay? So convex lens is for long-sightedness. The ability of the human to focus objects on the retina is referred to as accommodation, not interference. Interference is just, waves. Superimposed waves are said to interfere. Is that clear? And they can interfere constructively or destructively. You can check out my video on sound wave. You understand what that is. Then diffraction is the bending of light around obstacles. Now, a person can focus an object only when it is within 200 centimeters from him. He should use which spectacles to increase his maximum distance of distance vision to infinity. Now you know our near point, the human near point is 25 centimeters. So that they are putting 200 centimeters here does not mean it's long-sighted. The person is actually short-sighted because if you cannot, our far point is actually infinity. Okay, so if the person cannot see up to infinity yet, the person is short-sighted. All right, can only see near object, and more so 200 centimeters is just 2 meters. 1 meter, 2 meters. So that's how far the person can see. So the person is still what? Short-sighted. Okay, in fact, both of them are the same. So the person should still use what? Concave lens. All right, binocular is for seeing, for magnifying large objects at a long distance. Then plain glasses don't do anything. Okay, then convex lens. Okay, for is for magnifying. Is what the binocular also uses, convex lenses. All right, then which of the following defects can be corrected using a cylindrical lens? So myopia is concave lens, short-sightedness. Chromatic aberration is different, okay? The answer will be astigmatism, okay? Because presbyopia is corrected using bifocal lenses, okay? Bifocals, we call them bifocals. That is using both convex and concave. That's why we call it bifocal. Now for astigmatism, astigmatism is the one that uses cylindrical lens to correct. Now, what is chromatic aberration? I probably didn't explain that in the other video. Chromatic aberration is like, see, it is the reason why cameras don't produce some cameras don't produce very sharp image. Do you understand? For example, because they are prisms, when refraction occurs, the light ray, the different wavelengths of light that is refracting, they refract at different angles. So from red to violet, they refract at different angles. So because of that, they will now form fringes on the edge of the fringes of color, of different colors on the edge of the prism or lens in this case. Exactly. So because of that, the different colors that will form on the image in the picture, for example, will not be that sharp. That's chromatic aberration. And it's different from persistence of vision, because persistence of vision is when, for example, if you see an image run past you very quickly, speedily, something passes across and you can no longer see it, but just some minutes after it has passed, the image that you saw, that shape, that figure you saw is still showing in your eye. It's still you can still see it for a short while. That's what we call persistence of vision. Now, weak ciliary muscle results in which eye defect? That's presbyopia. That is also called loss of accommodation, right? Your loss of the ability of the eye to accommodation. Loss of the ability of the eye to focus image, the lens to focus image because of weak ciliary muscles. Do well to see those videos. God bless you. And subscribe to the channel as well. Thank you.